everyone. Good afternoon. So I got lucky and I got this lot where everyone is in the afternoon deep of energy, so everyone is kind of still like, kind of sleepy. So I don't mind if you take a nap. I just hope I'm not that boring. So my name is Rafael, as was on the previous slide as well. I'm originally from Brazil. That's where the accent comes from. But I live in Barcelona, where I've been living for the past 9 years. Beautiful city. If you haven't been, go visit. I work at Personio. Personio, for the ones that don't know, it is a HR management system. So basically, where your pay slips come from, this kind of stuff. We built that, and we're hiring. But this story is not about Personio. This story is not about my time at Personio, because I recently joined Personio. This story is about, the time that I was working at N26. I have a few colleagues here from N26. I hope they don't, they keep me honest. Thank you. So when I was working at N26, I was working as a principal engineer, and I was tasked to work on the financial crime prevention area of the company. And I was investigating our technological stack. I was investigating how you're preventing fraud. And I worked in previous banks before, and the world of banking is, more traditional banks is kind of batch-based, right? So it's basically, if you remember some years ago, when you send a bank transfer, it would always happen in 1 day or 2 days or something like this, right? And then the banks had a lot of time to analyze them and to detect fraud and money laundering, this kind of stuff. So N26, even though the basic static analysis and everything we were doing in real time, the more complex cases we were also doing a bit in a batched way, right? We had complex cases in real time, but the one that required lots of context, a lot of information, we hadn't. And then I went to look at our stack, I talked to my engineering managers and product, and I was like, hey, look, we need to make an investment to kind of modernize. And the main reason why is because the world is now real time. So the more we look at it, right? You cannot live without WhatsApp anymore. We cannot live without our real-time interactions. And banking systems are doing the same. So basically, now you send a peer-to-peer transfer, you send a SEPA instant, and things happen in real time. And we, as banks, we could not afford doing the analysis of, was this a fraud? Right? We had to try to do it beforehand, before it happened, and stop. This is basically to prevent loss and to act faster, so to reduce the time that we actually caught someone defrauding our customers or using our platform to commit fraud. The biggest challenge that we had was that we had a multitude of different sources of transaction and data. When I say this, I mean like, imagine every protocol that you have in a bank. You have like SEPAs, you have credit cards, you have all this. They're all coming from different sources. Most of them were Kafka in our architecture, but they're coming from different topics with different language and whatnot. So we needed something that would be able to aggregate all this, create some sort of view of the customer behavior, and then within that view of the customer behavior, we were able to basically analyze and detect whether this was a fraud or not. Okay, that's when I stumbled into Flink, which is a very distributed way of doing exactly what I said. The beauty of Flink, I'm going to talk more about it, but the beauty of Flink is that it can aggregate a multitude of data from varied sources, being bounded or unbounded data, meaning you can aggregate a Kafka topic with a database query and a HTTP request. And we were a Kotlin backend-driven whatever company, right? So our backends were all done in Kotlin, and we're proud of it. And we said, well, we looked into Flink, and we detected that Flink was like, okay, it is Java, there's a Scala, so it must work with Kotlin, right? Then in the beginning, it was just me doing proof of concepts, like seeing how it works. And the first things you see, like when you go into the Flink documentation, just to do like a quick start, you see this. You see Maven commands, you see Gradle scripts that are still groovy. So you're like, okay, it's just a documentation overlook, right? People are just not using Kotlin for this. It's compatible. It's not a problem. When you look at the examples that you see on the documentation as well, and many of the examples in the internet, everything is in Java or Scala, and that should have kind of given us a hint. And Yeah, this thing I think is really funny because when you look at the different ways that you can do Flink, there is a SQL way, which today I do not necessarily recommend. I'm not going to talk about that, but be careful. And there's a Python way that I haven't tried. We're Kotlin, right? So not talk about Python. So I should have taken a warn, like, this is uncharted territory. And to be fair, it was. But the thing is, when you look at Flink, I hope you can see the code, yes. When you look at Flink and the way you set up a job with Flink, this is the hello world, which is a word count code for Flink, basically the sample that is in the documentation. It's connecting to a socket, getting for every word that is given on the socket, using the splitter underneath to basically split by, I think it's by space, yes, by space, and then count the amount of times the same word appear. Very simple, easy, and then there's one line there, the datastream.print, that just basically prints it out. Easy, right? The thing is, we didn't want to write code like this. We would much rather write code like this, right? That is Kotlin way. Sorry for the formatting. I got it broken before I sent it to the presentation. But that's basically the same code in Kotlin, which is a language that we like, a language that is fun, that we wanted to use. So we decided to go ahead and, okay, let's do with Kotlin. I'm going to talk you through the journey that we went on the past year-ish, a bit more than that. Working with these things, not necessarily exclusively to Kotlin. There are some learnings here that are exclusive to Flink. I think they're available lessons as well. So this is more or less where we're going to focus on the thing. There are three big groups. It's concurrency, state management, and performance. So the first one is concurrency, and I cannot talk about concurrency with Flink if I don't explain how Flink architecture works. For the ones that are familiar with Flink, I'm sorry, I hope you learned something new. But basically, this is the Flink architecture behind the scenes. Flink, it's an absurd, complex task manager, and it is great at what it does, but it has a lot of complexity underneath. To simplify the architecture, basically, what you have is the first thing you have is a job manager, which its job is to basically understand the job that you publish to Flink. So basically, the way you work with Flink, you create your job, the thing that we've seen before, that is a job. The job manager receives this as a graph, so we have the graph with all the nodes, and it knows how to assign these tasks to the task managers that have different task slots, and then each task manager executes the task on its slot. Very simplified. There's much more underneath. There's an actor pattern underneath. There's a lot of things going on. If you're wondering where your code is, this is the part. Everything else is Flink, right? So I don't like to call Flink a framework because it's not. It's also not a library. So for me, it's a runtime. So it's not something that you basically, it's not like Spring that you throw your code in the right annotations and it kind of do the thing that you expect to do. It's not like Expose that basically you call it, right? It's more, yeah, I give you my code and you take it, run it. That's more or less how I see Flink. It's a runtime. What is beautiful for Flink, like one of the reasons also that we were looking at it, was we've seen major players using Flink. It was not necessarily a new technology. It was just that from my understanding and from my research on the web, no one was doing it with Kotlin. And we were like, yeah, we can do it. Just so you understand the sheer capacity of Flink, Alibaba in their last blog post reported they are processing more than 140 million events per second. Their architecture is not just Flink, right? They have a lot of things behind the scenes to make it achieve those numbers. But basically, this is powered by the engine of Flink underneath. Another cool thing about Flink is that Flink allows you to process your streams at the event time. So the difference is event time is when the event actually happens, and processing time is when the tool, in this case Flink, saw the event. If you have done Kafka streams, right, you know that if you're aggregating multiple Kafka streams, they have their own partitions. Each partition goes to a different instance. And if your partition is not keyed in the way you expect them for your aggregation, it's a hard time. You have to rekey it. You have to make sure that the topic makes sense, and it's a bit of a mess. I know there are other ways of doing this. This is not a Kafka streams versus Flink. But the beautiful thing about Flink is Flink allows you to have this extracted timestamp out of your event by a created at or a metadata timestamp, and aggregate them through all the partitions and everything. The way it does is with something called watermark. To explain watermark, the best anecdote I could think of, I'm sure some of you can think of a better one, please tell me later. Imagine you're building a tower, and then you have 4 people building this tower, and you have the 4 walls, right? So each one is laying those bricks in their own time, right? But they cannot see the other person. So if one of the workers is faster than the other, ultimately that wall will collapse. But you don't want also to be waiting too much for the slowest worker, and that's all. Imagine if this now is every brick is your event, and then the moment you were receiving the events, you're building the wall. The way Flink does it is that it puts a stamp on the bricks, basically saying, okay, this is, for the anecdote, this is the 1 meter mark, right? And then it tells the worker, keep working, and then it doesn't allow the distance to grow much further. If all the workers are in sync, if all the workers are delayed, you wait for the workers to be in sync. Of course, when you're talking about distributed system, this is milliseconds. You can configure. It's very smart way that you can configure. One of the complex topics about Flink, but it is not easy, not hard to understand. Why I'm explaining that? Why I explain all this when I talk about concurrency? Because when I learned concurrency first, this was, I don't know, 10 years ago, maybe more. I started as a Java EE developer, so the ones that did it cry with me a bit. It was like, how do you choose which executor to use? I want a fixed thread pool. I want a pull thread. It is a bit cumbersome. Then Kotlin came with coroutines, and there was also a learning curve there, not gonna lie, but it was much simpler. Like for me, for instance, that I already had the experience working with Java, it felt a bit natural. It does break your mental model a bit of the threads. But the point is, if you go back to Flink and remember the task slots and everything, each task slot in the Flink architecture is 1 thread. And then they're executing your tasks there, right? So the way you build concurrency within Flink, within the JVM, can clash a bit with the way Flink associates this task. It is a complex topic. In our project, we were like, we are not Alibaba, so we're not doing 140 million messages a second. So our thought was, yeah, we don't need it. Why am I adding this to my talk? I'm adding it because, of course, I did a lot of research for this talk as well. And one of the things that I learned was that for Flink, the way it's recommended to do more async and build your own threads and stuff is when you're doing I/O, like everywhere else, right? It's not that, it's actually quite obvious. So when you have your thread waiting for too long, this is when you want to do multi-thread, multi-currency within Flink. And this is when you look at, this is one example extracted for the Flink web page as well, that you can see here a bit of like boilerplate code and to do in an async function within Flink. So basically this could be calling a database, it could be making an HTTP call, whatever. And you have to go into all these hoops and loops to create your own thread factory, create your own stuff. Of course, I know this code could be simplified. This is just an example. But then this is where I personally believe coroutines could make a huge difference because the code is simpler, it's easier to read. We know that the overhead of coroutines, we can ignore this, and basically it will be good. Bit of a disclaimer, this is not code that we use. We haven't used coroutines, sorry. But upon reading about it, upon researching about it, this is where I think if I would give a recommendation where to go for coroutines with Flink, it would be on I/O. The next topic is about state management. This is a big one. This, I think, is the most important part of this talk. So if you're taking a nap, this is the time to wake up. So I have to explain a bit how Flink does state management, right? What is a state? So imagine you have, in our case, for instance, we had to look back in history and aggregate the behavior of our customers, right? We have to look back and see what is this previous transactions that this customer has done with us? What is the amounts that they have been processing, and la-di-da-la, all sorts of variables there. The way you can do this with Flink is that you can keep a state in memory. Imagine you're doing a window function, right? You have a tumbling window or a sliding window, and you have to keep the state of, as the window moves, Flink does this for you with the API, keeping the state of, okay, this has happened in this window, this happened in this window. Okay, things crash, things stop working. So Flink has state storage, let's put it this way. There's the local state backend, which is the one that Flink is operating while it's running, right? They have several implementations of it, HashMap, RocksDB, and others. And then at some point, before stopping a job or before a job crash or whatever, you want this saved to disk because you don't want to just have this in memory, right? So you can take like save points, which could be also seen as backups. Basically, so you store your state. There's also other stuff that you use save points for, but for the simplification, that's one of the main reasons. Great. Now imagine you have this very, very, very simple Flink job that basically read, again, words from a list of elements. Imagine it was the case from the socket, right? And then you're basically converting it into a data class, right? Very simple, right? This code is going to work. If you set up the state properly, you have a state backend set up. In this case, is not set up for the simplicity. But if you had set it up in your job, this will be saved in state as well. If you're getting from a Kafka stream, for instance, and you will know which events you had seen and all this, right? The beauty of it is that Flink has some assumptions in it, right? Flink was like, oh, people are going to be coding this in Java, right? So the objects that people are going to be used are going to be plain old Java objects, right? And if you've done Kotlin for a while, you know that a data class, it's not a POJO, right? And it doesn't follow the same kind of rules, right? So basically, what happens is Flink has to serialize this and create a binary representation of this in memory, because it sends this around in your cluster. It stores this. It has to create a binary representation of it. And when Flink does not recognize a class as a POJO, what it does, it uses Cryo, I'm always having a hard time pronouncing, I think it's Cryo, the serializer of it. And then this serializer basically creates the binary out of the class. My first experience with Cryo was some years ago when I was using Redis, and I remember I had a huge cache, and eventually we had to change the class that we were using the cache. We lost the entire cache. It was fine. It was a cache. Just repopulated the cache. No issues. I didn't know that we were using Cryo underneath here. So imagine now that you want to evolve your code, right? And then basically you add a new field to it. If you think in your brain, you're like, this is in a schema evolution. I'm just adding new things, so that's okay. But when you're using this serializer, there is a problem there. So think about it. Your state evolves, your program evolves. We don't build an application and run it forever, right? So when you deploy this new code, what Flink is going to do, well, not automatically, you have to do it. There's some manual steps on the way. But what you're going to do is you're going to stop your application. Sorry, you're going to save the state first in the persisted save point. You're going to stop your Flink job. And then you're going to restart your Flink job and populate the state, right? The point is those classes are binary incompatible, right? And Flink says like, no, cannot do it. We learned this the hard way, as you would imagine, right? We learned this in production. We learned this by basically starting a job, and the job was like, yeah, fresh new state, amazing, let's run it. And then we're seeing that we're consuming the entire Kafka streams again. And you're like, whoa, what's going on here? Stop the job, clean up topics, clean up data, clean up state, and like, okay, what has happened? Lots of research later, and that's what I'm trying to avoid here, like trying to help you guys not do it. We learned about the way serialization, and we learned this, right? Do not use Cryo like with Flink. Unless you're doing a proof of concept, please don't. Basically because it cannot be used for schema evolution. So if you add a field, if you change a field, whatever you do, it just breaks it. You have to have custom serializers. It's a whole shenanigan, so I don't recommend. There are more reasons why Cray is bad for your health, and you're going to learn about this later. So there's different ways you can solve this, right? My favorite line of code in the whole Flink thingy is this line here. They basically tell, do not use it, right? The name could be better, I agree, but basically it's telling you this code generates an error. So if you use this data class in your Flink job, it's going to raise an exception, and you're not going to be able to run your job. So there's different ways to fix it. You can basically make your data class Pojo it, ugly, vars, nullables, default. We don't like that. So there's other ways to fix it. This thing is not working. Okay, now it did. Okay, maybe I should come here. I should be better now. So there's different ways. You can have like custom libraries. You can have custom serializers. You can use other binary representations like protobuf or avro. But the most important advice that I can give you today is test your schema evolution. Because your schema will evolve, and you have to make sure that it works well and it evolves within your evolution of your code, right? How you test this? There are integration tests that you can do, and test in pre-production environments. That's the most important thing, because it will break there as well. For us, it was tricky because we did not have all the corn cases and edge cases in our pre-production environments. When we did it, we learned in production, and we had to take a hard time to fix it. But anyway, we learned this the hard way, so I hope you need to learn. You can learn from our experience. The other part that I want to talk is about performance and some hard-learned lessons. This is the less Kotlin-ish part. So it's things that we learned about Flink that are not necessarily about Kotlin. We could have made the exact same mistakes with Java. The same with the state, by the way. But we could have made the same mistake with Java or Scala or anything. But I think they're important lessons to share. So one thing that we do, I see my Anthony 6 folks there, they're like, eesh. So we were investigating a bug, right? We're just there looking at the bug and figuring like, why this not triggering? Why when this event happens, the state is incorrect? What is going on? So what every engineer does when we cannot recreate something locally and you have something in production, okay, let's add some logs, right? That seems very intuitive to do. We did add some logs, and we overdid adding some logs, right? The situation was we were generating 5 giga of logs per minute. Looking backwards, in retrospective, right, we should have known better. It was like, yeah, you were receiving a ton of events per second. It was not much, to be fair. It's like 100-ish. But it was still for every event that triggers your code, we were publishing 5 log messages. Oh, the event got triggered. This is the input. I did some calculations. This is the output. Again, I'm collecting my result like this. And we're like, this is going to look beautiful. Yeah, it created a lot of back pressure for our jobs. It created pressure in our Kafka cluster that was actually on the receiving end of the logs. I remember our SRE teams coming to us like, what's going on? You're hammering the log cluster. Please stop. And it had to run back and then like do a bit of a rollback and stop it. That's one thing that we learned. So remember when you're using Flink, Flink is really good at managing a sheer amount of events at scale. So whatever you put there is gonna be executed countless and countless and countless of time. So logs, for instance, is one good example. So if you're debugging something, if you're trying to figure out a bug in pre-production and production environment, log stuff that is like, oh, put some ifs, put some guards, put some guards, make sure that you log whatever makes sense, right? And not just, let me log the entire context here. One of the most important things that we needed to learn when working with Flink, was serialization. So why? Remember the structure that we had before in the architecture, right? You had the task manager, the job manager, and then we had the state. So all these things are basically happening in a way that Flink is serializing these objects for you and putting them in memory, shifting them to another cluster. When one task manager goes down, it recovers the memory from there, go back into state, sends to the other one. It's an actor pattern, so all the memory is flying around. And it's very smart to do this in binary, because if you think about the state, it's like a huge database, right? And the way you think about state evolution and the way you think about every time you change something in it, it's an outer table. So the way you do serialization with Flink matters. It matters really a lot. I think it's one of the most important things about Flink. And it gets kind of overlooked because it just works. So you write your job and it works. And you don't understand what is going on, and you're comfortable with the results, your tests are passing, and it feels like the word is magic and, let's have a beer. If you get it wrong from the beginning, it's painful to fix it. Another reason that I told you back then that Creo is bad for your health is if you see this is a performance graph of the serializers that Flink support. And this is where Creo is like, this is throughput per operations per millisecond. So Creo is like the very low bracket, basically one of the least performing ones. And the Pojo is on the fourth one. So basically, if your classes are Pojo, and there is one class in Flink called Pojo test utils that you can use. And you can basically give it the class and say, hey, would you say this is a Pojo? And Flink says, yeah, it looks good. So you can use it. If not, there are other ways. There is the tuple, which is a Flink implementation. Row, also Flink implementation. Then you can use, as I mentioned, protobuf, avro, and different ones. I am not going to recommend one or another, mostly because it depends a lot on the context. So if you have already your protobuf definitions because your events are coming from protobuf, might make sense to use it for serialization as well. If your use cases are simple, maybe the tuple works for you. The thing with the tuple is that the code looks ugly. So it is kind of hard to grasp, because the way the tuple works is that you have, so it's basically a list. It's like one object with multiple, like 1, 2, 3, 4, 5. There's, I think it's up to 25 that you can have. I don't remember now. So you can use it, but your code looks like, not great. So I'm not going to recommend a specific one, but what I'm going to say, and I'm going to say this with confidence, is make sure you understand serialization. Make sure you understand what the code is doing. Make sure you understand how the memory is being allocated for this. You don't need to go and scrap the bytes out of it. But there are tools, for instance, that you can inspect your state. You can look at your state. You can see how your state is looking like when a save point is taken, and you can understand more or less how the serialization is happening. So that's an important thing. Another important thing that we learned the hard way, another incident. There was a postmortem for this learning. So basically, is when you're coding with Flink, Flink creates a job graph, right? So you submit your jar to the Flink, or you run your jar, doesn't matter. And then it creates a job graph. So it's a graph, right? We know what is a graph. There's a root, there's some nodes, and then it goes there. So it's graph or tree? No, it's graph. So it creates a graph for you. The thing with this graph is, coming back to the state, imagine like Flink, every node in the graph has their own state. Because if your node is a data source, you're getting this data from Kafka, you need to know what's the last offset that you saw, right? If it is a sink, basically you putting this on S3, you need to know the last message that you put on S3. So every node has its state. Not only your stateful functions, right? The thing about the job graph is that Flink again says like, I can help you. I'm gonna make sure that I create a unique ID for your job, for every node in the graph, and I'm gonna use this as a key for your state, right? So the point is, when you try to reload the state, it goes back and it's like generate the key again and say, hey, I know where the state for this key is, let me get back. Now, the way this key is generated is based on what your code is actually doing, what this node in your graph is actually doing. So if you evolve your topology, your job topology, changing the graph, the IDs change, right? And then when when Flink is going to get the state with you, it's like, nope, I haven't seen that before. That's new. Let's start from scratch. So the code might not look the best, but this is more or less what you need to do. So for every node in your graph, set a UID, set a name. My personal opinion is that Flink shouldn't allow this to be optional because it creates a lot of issues, I would assume. But I understand they're trying to be like, oh, let's be more like friendly with this. This is an important thing. It's on the list of production-ready Flink jobs. So if you go to the Flink website, there's like, oh, how can you make, be sure you do this before going to production. We did this after, as I assume most of you would. It was painful. So the way you have to recover from this is that basically we deployed, and then we saw that we were starting from scratch again, cleaning up topics, and like, okay, what have we done wrong this time? And then when we realized what it was, we had to roll back our code, go look into the state, see the generated IDs, right? Copy those generated IDs back into our code, right? Redeploy with the new generated IDs, then we could change. Don't go this, don't do this, don't go there. It's painful. So I'm trying to help you avoid this. The other thing is right-sizing your operations in your job. The main importance of this is, again, Flink is powerful, right? But every time you deploy a new version of your code, not necessarily in this order, these are not extensive list of steps, this has to happen, right? So it has to pause, save your state, your save point, stop your job, start the new deployment, resume, restore the state. This is blazing fast, yes, but if you have a gigantic job with gigabytes of state, that's not so fast. And Flink, it's not optimized for zero downtime, so you cannot actually run those jobs at the same time while one learns from the other. You have to actually stop and then start again. There are ways to do high availability with Flink. Not going to get into this. Mostly you won't need it unless you're doing like what Alibaba was doing. Because it's just like a split second, it's a couple of seconds that you need. So you have like little downtime. If you're just processing events, usually you not have a user waiting on an HTTP, waiting for your call, so it's okay. So most of the cases, that should be fine. But if you start building a job and the job starts building and growing and growing and growing, these steps are going to start being more painful. So what we learned was create your jobs, maybe, split them out, have in your state just stuff that makes sense, and do like right-size operations. Make sure that you don't overdo. Let's start this state just in case we need, right? So the jobs also become smaller, and you can also have, okay, this job does this part of the work, this job does this part of the work. They can communicate through a Kafka topic or whatever other means of communication, and it's easier to maintain the life cycle, it's easy to deploy. And last but not least, one of the things that is important for us that we realized was that profiling is still a thing. Make sure you're not overdoing in your functions. Make sure you're not overdoing in your when you're doing your calculations, just so you understand what your code is actually doing. There's tons of profilers out there. Many of them work with Flink. We've tried some. It's not that hard to do. You all have the experience with profilers, so I'm assuming you're going to be good with doing it. But the message is do it. Right? When you start actually building your jobs and you start having performance issues, profiling is your best tool. And if you're using Flink, I assume it's because you want real time and you want things to go fast. So it's important that you also take care of this part. A bit of a recap. So basically, Word is now real time, remember, so these solutions are going to start popping out more and more and more and more. Flink, I think, I was in Kafka Summit last year, and I think 1/3 of the talks were about either Kafka Streams or Flink, maybe because Confluent bought it. Like the other part is Flink is a beast. Like it really can do amazing things. I think it's still an underappreciated piece of technology. I think it still has to evolve to be more friendly for newcomers, to be fair, but it is a beast, and it's impressive what it can do. Kotlin is fun, and I know some of you would be like, okay, would you recommend using Kotlin with Flink? And the answer is yes. there are some of the things that, make sure like you understand how, you're serializing. It's not just a drop-in kind of replacement. You need to be mindful of the differences between Java and Kotlin, because Flink does have some assumptions about how the JVM has been used underneath. User coroutine for I/O, go wild. Your state will evolve. It's one of the most important things that you can take from this talk. Make sure you test the evolution of it, add in new fields. What happens with the whole history that I have in production? If you remove a field, if you rename something, if you add more to your state, test it extensively so you don't have a crash in production like we did. Log wisely, and by log wisely, what the message is, everything that happens in your process functions happen quite often, so make sure that it makes sense. Serialization can slow you down, so if you don't get it right, it is painful to recover and fix it. So spend some time to actually understand how the serialization work and have a huddle with the team saying, hey, what do you think is the right framework of serialization for our job? I think that's something we also learned the hard way. It shouldn't be optional. It shouldn't be. There should be a flag or something saying, if you don't set fail, maybe there is, and I just don't know about it. But it is, when you evolve your job graph, this can be absolutely painful. Keep only what matters in state, and I forgot the last part, which was, and keep your jobs small. So it's easier to manage multiple jobs than one huge job. And profile application. And that's what I wanted to share today. I hope not many of you got bored by my talk. Thank you, and I appreciate you being here. We have 8 minutes for questions if you have any.
Hello. Great talk, thanks. Did you look at Kotlin X serialization?
I did on my proof of concepts. It works. Although Flink does not have, Flink has its own kind of serializers, right? So what you can do, you can create your custom serializer for Flink. You can have your custom serializer, and Flink will kind of understand it. So Kotlin serialization works. I haven't used it in production, so I cannot tell you whether it's more performing, less performing. I haven't done the benchmarks as well, so it works, but I would recommend you be a bit cautious about it.
For the compile time safety. Sorry. But you have to.
For the, I asked because of the compile time safety with the required annotation, it would maybe provide some benefits.
Yeah, I did on my proof of concepts and it worked. Like I created my custom serializer and it worked, and I did because I was as curious as you with the same thing. I didn't include it in the talk, but it worked, and it was like, okay, this is one way of doing it. Since it's not on the benchmark and nothing, I'd just rather not mention. But yeah, it's definitely one way. Any other question?
Thank you. Hi, nice talk.
Thanks.
So one of the things you mentioned is with Kafka Streams, obviously you have the partitioning of your events. And I think you actually answered this, but I might not have, I don't think I understood. So how do you deal with events that have some sort of relationship between them?
So this is one of the things that I particularly like about Flink, because it merges bounded and unbounded data in multiple streams of data using this watermark measurement, right? And the way it does is, as your streams are advancing, it just basically marking your streams. So regardless of the partition, regardless of where they come from, the watermark is the one that gives you, I've seen this event, I haven't seen this event, I have seen this event, right? So if you, of course, it's better if your streams are keyed in a way that is important for you. You can now, so within Flink, say, okay, let's key this one by this field or whatever. But the way Flink does is with this watermark concept. Right? Basically, make sure that all the streams, if one of the consumers, one of the jobs is getting too ahead of itself, it basically rebalances it by waiting for the orders to recover, and then it comes back in. We had some issues with it. It was really hard to set up a proper watermarking strategy, but once you kind of understand and once you learn how it works, it makes sense. Any other question? And we have some Flink specialists in the room as well. If you want to ask them, they're there somewhere. Okay, thank you very much. It was really great being here. Enjoy the rest of the day.